Now that you've gotten a taste of Java programming, let's get down to business with Android. Android refers to a collection of software components that run on mobile devices like phones and tablets. This software provides the operating environment to do everything from displaying text on the screen, to sending and receiving phone calls, or to running apps like the one you're about to write.
I thought Android was just the name for that little green robot.
Oh, he's just their handsome mascot. Oh, not as handsome as you, Mike. Don't worry. Making apps for Android requires a few free tools. Installing the proper versions of the tools and getting them hooked up correctly can take a little time. So instead, we bundled everything together that you need and made these available as downloads. The bundles are available via the link on this video page. Visit the link and select the bundle that matches your operating system. Go ahead and pause me while it downloads. I'll wait. Unzip the bundle once it's downloaded. After it's unzipped, we need to run a small setup script called initial setup. Make sure you unzip or copy this bundle to a good location on your computer because if you move this bundle after you start using it, then you'll need to run this initial setup script again. Double-click on initial setup, and once it completes, we should be good to go. Okay, we're ready to start programming. Let's get started with our Crystal Ball app. We're going to approach this as an iterative process, and we'll start with a very simple version that simply displays the answer yes all the time. It won't be very useful or fun yet, but it will introduce us to the tools we'll use, as well as verify that everything is working correctly on our computers. Now let's open Eclipse. This is the program we will use to actually write code. Eclipse is a software application known as an Integrated Development Environment, or IDE, and it lets you write, build, and test your Android apps. Okay, let's create a project for our app by clicking on File, New, Project, then expand Android, select Android Application Project, and click Next. Alright, we'll start with the application name. Notice on the bottom the text that says, the application name is shown in the Play Store. Let's type the name exactly as we want it to appear in the store and on a device. Crystal Ball, with a space, a capital C, and a capital B. The application and project name can only consist of letters, numbers, or underscores. Next up is the package name, which is already filled out for us with an example package. We'll use this despite the warning that says it's a placeholder and should not be used. Using com.example is a common convention for test projects or apps that won't go into an app store. Normally, we would use our organization's website in reverse notation as the package name. So for example, I would type com.teamtreehouse instead. You can use pretty much anything you want here, like your own name, but for now, let's just leave it as com.example. The package name should be all lowercase and without any spaces. The package name is important because it is used to differentiate our app from others in an app store. If there is another Crystal Ball app on Google Play with the same name, then we need something besides the application name to tell them apart. That's where this package name comes into play. And one more thing about the package name. If we were using the Team Treehouse package name, and Treehouse wanted multiple apps on Google Play, then we would need to differentiate them even further, which is why the project name is appended to the package name. This way, other Treehouse apps could use the same com.teamtreehouse prefix. Okay, for the minimum required SDK, select API 7 Android 2.1 Eclair. This way we can run our app on virtually any device currently in use. Leave the rest of the fields alone. We'll target Android 4.1, which is the latest Jelly Bean release, and for now we'll use the default Holo Light theme. Click Next, uncheck Create Custom Launcher icon, and click Next again. The next screen shows us 5 templates we can choose from. We'll use the first, the blank activity template, but if you click on the others, you can see a little preview of what they would look like. Full screen activity doesn't have the action bar at the top. Login activity includes some default fields and a button. Master detail flow is like Gmail, which can show a list and a detail together on a tablet, or just switch between the list and detail views on a phone. And settings activity is set up for a list of editable settings. Select blank activity and click Next. Leave everything as it is on this screen and click Finish. Okay, we're almost done with this first project. Eclipse has done most of the work for us, so let's just take a quick look at what has been created. On the left-hand side, there should be a view called Package Explorer. If it's missing, you can reopen it or other views by going to Window, Show View, and then selecting the view that you want to display. In Package Explorer, the Crystal Ball folder contains everything in our project, just like a folder on our computer. In fact, an actual corresponding folder has been placed in our workspace. Notice how the directories here match up with those in the Eclipse project folder. We'll cover all of this in detail later, but for now we're going to look at the Res folder, which stands for Resources. The resources for an app include everything that you see or hear, so this is the place to store images, sounds, and screen designs, or layouts. Inside Res is the Layout directory, and in here we have the activity main.xml file, which has already been opened for us. So what we have here in the middle is the design for how the main screen of our app will look. This Eclipse view is called the Graphical Layout Editor, and it is a drag-and-drop editor that lets us visually manipulate the screen layout. In Android, this screen layout is encoded in a file format called XML. We can switch to the plain XML view by clicking on the Activity Main.xml tab at the bottom. These two tabs show the same file. One shows the XML code behind the scenes, and one shows how it will be rendered on a phone. We could build and run the app right now, and it would display the screen on our Android emulator just like it shows right here. But I'm feeling adventurous, so let's make a change so the app says yes as an answer to our questions. Right-click directly here on the Hello World text, and then select Edit Text. We'll talk about this string resource business later, but for now, just type "The answer is yes" down here at the bottom. Click OK, and view your change on the screen. Alright, there we go, looking good. Before we go any further, let's save our change. Click on the little save icon up here at the top, or you can use keyboard shortcuts to save. Command+S for a Mac, or Control+S for Windows. That's all for now, but before we try running our app, let's just take a quick look at how Eclipse lets us know if anything is wrong with our project. At the bottom of Eclipse is a view called Problems. I have mine minimized, so I'm just going to pull it up. This is where warnings and errors in our project will be displayed. We have one warning about using a hard-coded string, but we'll look at that later. We can ignore some warnings like this during testing, but it's generally a good idea to fix them as soon as they show up. But we do have to fix any errors that show up here before we can run and test our app. Warnings like this are shown in yellow and the errors will appear in red. Another place where different kinds of problems might show is in the console view, which is this tab over here. This is the Eclipse console, and it shows information about the Android emulators or any connected Android devices. So if our app isn't loading to our emulator, this is a good place to start looking into what the problem might be. We should be error-free, so click on the green Run button at the top of Eclipse that looks like a play button. That should bring up a little Run As dialog, but it doesn't because our focus is still down on the Console tab, and we don't have anything selected to run. So if the dialog doesn't open, we just need to select anything over here in the Package Explorer or in the code editor. Doing so just tells Eclipse which project to run, which is helpful if we have multiple projects open. Now before we try and run our project again, let's check and make sure that our AVD was created correctly. Up here at the top are two buttons, the Android SDK Manager and the AVD Android Virtual Device Manager. Click on that one. Now you should have a device that shows up in here, but if not, let me just show you quickly how to recreate it manually. I'm going to delete mine, and then click on New. Type in the name Android 4.1. For the target, select the Android 4.1 API, and click Create AVD. That's it. Go ahead and close this. Let's click the Run button again, and this time we go right into a launch. Now you may be presented with a dialog that has a list of choices, and if so, you want to select the first choice, Android Application. If everything is set up correctly, our Android emulator should start, and our app will be loaded into it. The emulator may take a long time to load, so just be patient. As long as the word Android shows here with the light flashing across it, like this, then it means that your emulator is loading. I once had to wait over 20 minutes for an emulator to load on an old computer. But once it's up, you can leave it running to avoid this wait on subsequent runs. Alright, check it out. Let's ask it a question. Will I become an Android master? Hey, what do you know? The answer is yes. We should celebrate. We just created and ran our first Android app. Not bad for a few minutes of work. We used Eclipse, the Integrated Development Environment, or IDE, that's recommended for Android development. And we saw how to change the text of a label. Coming up, we'll make some more changes to the screen layout, and then we'll write some actual code.
Can't wait.